I'm Tammy Kolda, an applied mathematician, and this is Unlocking LaTeX Graphics. On this YouTube channel, I am providing a detailed how-to guide on TikZ and PGF plots. I've been using these tools for a long time, so I understand your frustrations and hope to make your lives easier. We're working our way through the contents of my book, Unlocking LaTeX Graphics, which is linked in the show notes. If you like this channel, please subscribe, post questions, and share with your friends and colleagues. Today's episode is focused on creating curved paths, and I'll cover two different ways to do this. The first is using the arc path command, which traces out part of the arc of a circle or an ellipse. The second, and my preferred method, is the topaths command, which allows you to do paths that have bends in them. I'm assuming you're already a little bit familiar with TikZ. If not, please go back and watch my earlier episodes, which are linked in the show notes. As usual, we'll be creating our LaTeX document over at the overleaf.com website. So let me go ahead and start a new project, a blank project. We'll call this project Curved Paths in TikZ LaTeX Graphics. So we'll go ahead and start that. I'm going to close out this left-hand side just to make things a little bit less busy. And then I will set up the top matter. So let's paste this here. So recompiling, we're using the TikZ package, which we'll need for our graphics later. We're using the topaths TikZ library, which is a special library that we're going to be introducing in the second half of the video today. Then we're using the arrows.meta library, which we've used before, and we use that to make some pretty light arrows later. And then we'll use some packages just to make our formatting nice, parskip and full page. And then hyperref is so that I can have the author here link back to the YouTube channel. An arc is a path operation that traces out part of a circle or an ellipse. It does not require any special TikZ library. To get started, let me go ahead and paste a little segment of code here to set things up. So what I've created here is I'm drawing a circle at the coordinate 2, 2. Doesn't really matter, but I put the circle there. And then I colored it with a little purple circle. You can see where it is. And then I'm tracing out a circle of radius 1.5 around that. I've covered name coordinates and circles in previous videos linked in the show notes. Now let me draw an arc alongside the circle using an arrow. We've covered arrows in a prior video, so I've also linked that in the show notes. Let me paste the little segment of code that we need and compile this. Now let's zoom into what we're doing here. The first thing I'm doing in this command is I'm creating a coordinate named cyan, which is at 45 degrees and a distance of 1.5 from this coordinate purple right here. Now we're drawing an arc starting at that point cyan, and then we're drawing along this circle of radius 1.5 until we get to the end angle of 135 degrees. An important thing about the arc is that the starting point is on the arc itself. In this case, we are starting at that cyan point. It's at angle 45 degrees. And a radius of 1.5. We get different arcs if we change things up, even from the same point. So let me give you another little example here. So if we compile this, we've drawn a second arc here in teal. And the only difference here is I've changed the starting angle to 0 and then the ending angle to 90. It's still a 90-degree sort of sweep, but now it thinks that the starting point is at a different point along the circle. And so it changes the resulting arc. As an exercise, which I hope you'll do, can you find that circle's center and draw a point there and then draw the circle that's underlying that arc using the circle command? So if you can figure that out, you're mastering TikZ. We can also change the radius and get something different. So here's the same thing as the first arc command, but I'm just changing here the radius of the circle. I change it from 1.5 to a radius of 1. That's the only difference. And now we see, again, it's carving out a slightly different circle. So again, as homework, can you figure out the center of that circle, put a point there, and then draw that circle that's being traced? Now we can also go the opposite direction along this arc. So if you wanted to go the opposite way, how would we do that? So I'm going to paste some code here. It's sort of the same thing, only now we've gone the opposite direction. How did we accomplish that? Well, the start angle is the same, 45 degrees. The end angle, now we've made it less than 45. It's at minus 225. It's actually the same point as 135, but because we made it less than, it causes the arrow to go to the right rather than to the left. Now, we're not limited to circles. We can also trace out the arc of an ellipse. If you remember from our prior episode on circles and ellipses, you can get an ellipse by just specifying x radius and y radius to be different things. The same is true with the arc. So here I'm drawing an ellipse using that circle command with an x radius of 2 and a y radius of 1, centered at some point illustrated here as a gray dot, and we'll call it gray. Now I'm going to draw an arc along this ellipse. I've created a starting point that is at the distance of 2 angles 0 from the starting point. So it's at this apogee of the ellipse. And then we're going to trace it around from angle 0 to ending angle of 75 degrees. Now, if you don't want to start at an axis aligned starting point, it gets really tricky to find that starting point. And remember, you don't start at the middle, you start at a point along the curve that you're tracing out. So here's an example where we start at a point that's along the ellipse. So this gets kind of complicated. How did I find this cyan point? Well, I started at 0, 2, and then I went to an angle of 135. So I started from 0, traced over to 135 with my x and y radius being as before. And then I created a coordinate at that point named cyan. And then just to make it so that we remember where it is, I put a cyan colored circle there. Now, starting from that point, I draw an arc and I tell it has a start angle of 135. And then I have it have the end angle of 90 and then the x and y radius as before. We could say we want that arc to go in the opposite direction as before. If I make this 450, it'll go the opposite direction. So you can play around with this. Now, this is all pretty complicated at this point, if you ask me. And I think there's an easier way using the topaths, unless you really just do want to trace out the arc of a circle, which there are applications for. But let's go to an easier way in the next segment. The much easier way to draw curved paths, at least in my opinion, is to use the to replacement for the line to operator. This is something that requires a special TikZ library called topaths, which we included up at the top of our document, and we'll now show how to use that. Let me scroll down to the end and paste a little segment of code and compile it. And then we'll scroll down to see the code and to see the little picture that we made. So here we have a picture that I've created 2 coordinates, a yellow coordinate and a pink coordinate. And now I'm drawing a line from yellow to pink, and I've put the to command right here. So this means that this is really just a replacement for the dash dash. If I were to change that up, it makes no difference, but we're going to go ahead and put in the to command. And this is an alternative way to create lines. Now, what's useful about the to command is that you can do other things. You can bend it, for example. So let me redo this exact same picture and change the in and out angles of this to operator. So here I've put the out angle is -90 and the in angle is 180. So if we look at the result here, I go -90 degrees outbound from yellow and in 180 degrees from the pink coordinate. So just so you can see how this sort of tracks, let me draw the 2 lines that sort of correspond to the angles that we're wanting. So here's the -90 degree angle coming out of yellow, and you can see it starts off at that angle, and then you can barely see this dashed line coming in at an angle of 180 into the pink coordinate. The angles can actually be really extreme. So here's an example where it's quite different. It's almost going the wrong way when we start and end. We're also going to go ahead and start at pink and go to blue just to make things different. So we have out being at 0 degrees, so it's coming out the wrong direction. It's able to successfully curve around and come back in at an angle of 135 degrees into the yellow. So this bend command is quite flexible. Now, sometimes it can be hard to figure out the angles that you want when the lines are slanted. So one thing you can do is you can use relative angles to make things a little bit easier. So let me give an example here. So here we have the keyword relative in our topaths. So let's file that and see what that means. This means I specified an out angle of 60 and an in angle of 120, but that is relative to this diagonal line. So 60 degrees going out and then 120 degrees coming in. Remember, it's measuring from over here going to 120 degrees. The symmetry is really nice. If we made this, for example, 75, you may or may not like that picture because the outbound angle is a little bit different than the inbound angle. If you like the symmetry, then there's actually a shortcut that you can use called bend left. I'll give you an example of that. Bend left is a shortcut for out equals angle, whatever angle you specify. Here we're specifying 60. This sets in equal to 180 minus that angle, and then it adds that relative command. So bend left accomplishes a lot for you in a much less space. And then I can play around with that angle. I could make it, say, 45 degrees instead. The direction can be thought of the left or the right as which way you want the path to go. If you're standing on the first point, in this case, the yellow point, and you're going to the second point, in this case, the pink point. So the curve is on the left if I was standing there. We can also bend right, and that goes the opposite direction. So let me show you an example with that bit of code. And bend right is just a shortcut that handles the angles a little bit differently. It sets the out angle to be 360 minus whatever angle that was, in this case 60, and the in angle to be 180 plus alpha, and then it also makes it relative. So this makes things a lot easier. I hope you've enjoyed today's video. We've seen two ways to draw curved lines using the arc path command or the to path operation with various inputs to that operation. Let me know if you have a preference for one or the other. I really like the two paths method. There's a link to today's Overleaf document in the show notes. Please click like or subscribe if you want more videos like this. You can also buy my book, Unlocking LaTeX Graphics, at your favorite book retailer. Thanks for watching.